All right. Let's see. There we go. Okay. Good evening, everyone. My name is Jeremy Osborne. I am currently the director of Winter Mountaineering School, ADK Winter Mountaineering School. We're an all volunteer instructor corps that comes from being a student at the program and then invited to come back as an instructor. I've been doing this for a little over 10 years, I think, at this point, between my student year and then instructing years. Um, and kind of a little bit about us. We operate out of the lodge at Heart Lake in the Adirondacks, and then we, for the past several years, have been operating in March out of the White Mountains at various locations, running day hikes, overnight winter mountaineering programs, teaching fundamental basic mountaineering skills. And this year, obviously with COVID, we canceled the in-person workshop and exchanged it for these Zoom calls, Zoom informational meetings. And we're running a handful of these through the middle of March, one a week every Wednesday. We're in the process of kind of figuring out how we can upload these to either a YouTube channel or a Facebook group or something, so that if there was another one you were interested in seeing and didn't get to, you'll probably be able to watch it at some point. Just keep checking our website. And so, like I said, I'm Jeremy Osborne, and then my co-instructor tonight, the person really in charge of this presentation, is Amanda.
Hi,
Go ahead.
everybody. My name is Amanda Carpenter. I am in my day job a research scientist and I study air quality and I really love winter weather and forecasting. So I hope I get to share some of that knowledge with everybody tonight.
Do you, Amanda, do you want me to share the presentation, or do you want to share it? Screen
Uh,
share.
if you have the opportunity to do it,
I do. Give me just a second. Mm, There we go. Oh, I'm at the last screen, not the first screen. Hold on. Still not a good zoomer yet. There we
so
go.
awesome. So again, we wanted to teach a little bit about winter weather and how it relates to, the mountains and hiking. Weather can really make or break a trip. And especially in the winter when we're dealing with breaking trail or exceptionally cold temperatures, it becomes extra important because you need to be thinking about your gear, so far ahead of time. So hopefully everybody will be able to take something from this presentation today. If you want to go to the next slide. So just a quick overview. We're going to look at mountain weather and kind of what goes into orographically forced and influenced forecasts, winter weather forecasting, choosing the right forecast. So there's a big difference between different websites and different things people can look at. So kind of showing what some of the important stuff will be and choosing the right gear for your trip. Now, with winter weather forecasting and mountain forecasting, you can go to entire university semesters on any one of these topics. And because we have kind of a limited time tonight, we're almost going to be skipping a rock over the water and touching on some of these individual topics to make sure you guys have an arsenal to be able to understand some of the things that go into winter weather forecasting. We can always go into more depth. We're going to have time for questions at the end, but there is going to be some resources at the end if you wanted to learn more about any individual topic. Next slide. So, mountain weather. Um, so, one of the first things when it comes to any sort of interesting terrain in weather forecasting is that the weather models get really, really complex, really, really fast. There's so many interconnected processes that go into numerical weather prediction models, and not all of them really do a great job when it comes to really complex terrain, especially in the Northeast. Um, a good place to look at some of these weather models, it's a service called eWall that the Pennsylvania State University has, where you can see all of the different weather models kind of in one spot. I'll go to the next slide. So this is kind of what I'm talking about when it's kind of hard to um, see some of these weather models kind of skip over parts of mountain ranges. So keep that in mind when you're looking at the forecast, for any large part. I do a lot of my hiking in the Adirondacks. So most of the stuff comes from the National Weather Service in Burlington, Vermont, or other spots that the weather models really can't resolve mountains very well. So then we have to, rely on the expertise of individual forecasts or kind of what our own knowledge is. For example, a lot of forecasters use the GFS model. It can only do about a 13-kilometer grid. So we lose a lot of interesting stuff within that 13-kilometer grid. You can lose entire ranges. So keep that in mind for certain terrain features. Next slide. So mountain weather. What happens on an individual summit or an individual valley is really going to be determined about the characteristics of the larger air mass. So, when something's coming through, the humidity, the wind speed, the direction, all of that's going to be really important. And it's going to be even more forced when it comes through different mountain ranges. To my notes. So things like fronts or cyclones that are happening, in the larger area are something to keep in mind when you're looking at an individual summit. Clouds and precipitation microphysics will determine kind of what kind of precip we're going to have, if it's going to even show up, and certain terrain characteristics will set up how a air parcel will move over a mountain range. If it will move over a mountain range, sometimes it can go around. You can have different valley forces. And if you want to learn, do a really deep dive in some of this, and you feel like some of this is going too quick, the University Corporation for Atmospheric Research has a module for dynamics and microphysics of cold season orographic storms. There's you can Google it, and it's a hour and a half class, I believe. So if it's something you just want to learn just about how storms can move over mountains, that's something available for you. Next slide. So orographic uplift, I keep saying orographic uplift a lot. It's kind of how storms can move up and around mountain ranges. So a lot of us have been hiking, and we'll notice that the conditions you will find kind of at the trailhead can be bananas different than what you will see not only at the summits, but on the trail and in the cols. Mountain ranges can block the flow within a larger system. So what a low pressure system moving through might be causing almost no rain in a valley could cause it to rain at the summit. Or, on one side of the mountain, you can have a lot of snow, and the other side, you can have almost nothing. Um, and also mountains can almost create their own weather. In the summer, you see this a lot where it's perfectly fine in the valleys, but as soon as you get to a summit, you get no views. 3/4 of my hikes in the Adirondacks, you see a lot of clouds because mountains kind of can create their own weather, and it's really interesting and makes hiking a lot trickier. Orographic clouds, so orographic is, terrain force can form also ahead of a larger storm system. So if something's supposed to be coming, a couple hours ahead of time, because the mountain is forcing the air upward, you can start seeing some of those clouds and stuff way ahead of time. And snow can have a lower moisture level in the mountains than in the valleys. It might mean that the snow would be easier to pack at the trailhead than, on the trail or at the summit. Next slide. So when there's when we're talking about mountain ranges, there's kind of two sides of the mountain. On the left side, you can see it's kind of the air is going up and over the mountain and condensing the water vapor. So, moist air rises and you'll have a lot of precipitation on one side as that air is being forced up and over the mountain. On another side of the mountain, you would kind of have a shadow effect where you'll have a lot less precipitation and you can have kind of this dry descending air. So, for example, if you were doing a hike where you had to go up and over a summit, if you were going to come back from Gray and Scarlet and had to go over Mount Marcy, depending on which direction a storm would be coming from in the days and weeks ahead, you can have pretty different snowpack and you can have different weather and wind on one side of the mountain than the other. You can even have views on one side and not the other. And this becomes, something to think about when you're hiking is, one side of a mountain range could have plenty of snow. It could be really great for snowshoeing, but on that dry side, you might have to spend the entire time in crampons. So it's, mountains can create their own weather. Speaking of, next slide. So types of mountain storms. There are about 30 of these. I picked the two that I most commonly see when I'm hiking. Again, I do most of my hiking in the Adirondacks. Stable upslope storms, I see plenty of, where the air it's a kind of a stable air mass. So if that air mass were to be moved up or down within the atmosphere, it kind of sink and fall and go right back where it is. It's kind of happy where it is until it's forced up and over a mountain due to the wind. So it would create, precipitation kind of just at the summit. If it's cold enough, you can just have snow in this one spot. And we've all seen it where we've looked up about where we're going to hike and we see this entire, mountain summit is covered in a cloud. So it's, if there's enough moisture, if the air mass is stable enough, it can just create snow or rain in that one spot. And you'll have more, again, on one side of the mountain range than the other, or just individual mountains. Now, the Adirondacks can get sometimes really complex because depending on the storm path, a storm's going to encounter a lot of different mountains before it can maybe get to yours. For example, if you were doing Giant and Rocky Peak, if something's coming from the southwest to the northeast, it's going to come in contact with a lot of different places where kind of the storm can be squeezed out of moisture before it gets there, but it always really depends. Next slide. And then one of my favorites, cedar feeder. So in the atmosphere, we might have, what otherwise would be precipitation that wouldn't reach the ground. So it would be, it'd look really cloudy and dark and yucky for the day, but we really wouldn't get a lot of snow in a valley. But going up an orographically forced storm, as that air moves up that mountainside, it kind of becomes more concentrated in its moisture. So and I'll talk more about this when we're talking about, snow forecasting. When you have to look at snow forecasting, the snow needs something to stick to in order to form. So you need, you can have all of the super cool droplets, you need in the atmosphere, but unless there's a condensation nuclei, so if there's a, pollution can be a condensation nuclei, ice crystals, unless there's something, snow isn't going to form. So these are really cool when you have, kind of a cedar cloud, something that's dropping precipitation down and it wouldn't hit the valley, but because this orographically forced mechanism, you're getting this little spot of snow that wouldn't otherwise be there. So I've seen this, I think on Giant a couple of weeks ago, where it just this little spot. It was really, really cool. but it's, is something that, I've come in contact with. You'll see this all the time when you're in the Adirondacks, but it is pretty interesting. Next slide. So forecasting winter precipitation. The next one. So in the larger sense of forecasting, one of the questions is, why are weather people always wrong? And why is it so difficult to figure out in this one spot, what is the weather going to be like? Now, mind you, all of this becomes a lot more complicated when you have a really complex terrain. But when you think of what we actually have to do when we're forecasting the weather, everything is really viscous in our atmosphere. And this is one of my favorite quotes whenever I get yelled at for a busted forecast of, we have this rotating spherical envelope, mixture of gases, murky, somewhat viscous, what our atmosphere is. It's sticky, it's complex, we're heating it unevenly like a lava lamp, and we're tilting it back and forth. So when we're thinking of forecasting, days and weeks in advance, you have to keep in mind it gets really weird really quick. And then even more so when it comes to winter weather and orographically influenced, so complex terrain. Next slide. Share my notes. So as I said, winter forecasting is really difficult. Some of the weather models aren't great. We've had already so far this season a storm that was only supposed to produce in Albany 3 to 4 inches, give us about 36 inches. It was horrible because I had to shovel all of it myself. And different, it's like, where's all my friends? Where's all my friends? They all have snow blowers. But certain weather models do a lot better job than the other. I will usually use the Canadian or the European model when I'm looking at snowfall forecasts. And you can see these different models on, you kind of Google the name, there'll be a couple places where it comes up. EWAL is another one. Tropical Tidbits will have a lot of good information. And why it gets so complicated is because there are so many interconnected microphysical processes that take into, effect of how much snow, when is the snow going to be there, what is the, I have some notes here. What's the rain snow? How is that going to change over time? So what might be a great forecast going through Lake Placid, because we kind of know the terrain, will be completely weird by the time it gets to, any individual summit. And one of my notes I have, I think in the biggest sticky note known to man on my desk, is the heaviest snow tends to be around 850 millibars, depending on the temperature and what the thickness is. And, the type of snow forecasting also can be very complex. You want to hit the next slide? So this is some stuff about, so, it's not just snow, a blanket term. There's a lot of different types of snow. And if you ask any skier, there's good snow and there's bad snow. And there's a lot of individual processes that go into what makes, what makes snow happen, for a lack of, a cooler term for that. The temperatures have to be kind of just right. The how the column in the atmosphere has to be just right. And, there are, looking at my cool notes. So, there's all of these different things that go into what makes snow. And if I were to go through every one of these for this time of night, I think everybody would be very, very bored. There's, a lot more in this. I think there's about a 3-hour presentation that you can look at just with all of the different microphysical processes that go into snow. But the important point of the slide is that condensation growth drop cloud droplets, so kind of in that middle part. So everything needs something to stick to. You can have super cold air, you can have the perfect terrain for forcing, but if there's not condensation nuclei, snow isn't going to happen. And sometimes we don't entirely know why or why not that doesn't happen. Um, and that's when it comes to that condensation nuclei. One of the things I like to point out to my nephews is when you melt snow, because sometimes we have to melt snow to get the liquid equivalent to see, okay, how much water was in the snow. When you melt it, it can look like really kind of gray and yucky, because sometimes air pollution can be one of the things that the snow can build off of. It's part of this, stuff I study in my day job, but um, different condensation nuclei can also create different types of snow. Um, and other notes I had for this slide is the dendritic snow. So kind of in that center plate column is kind of the powdery, low density snowpack that typically will have large amounts of snow, kind of easier for shoveling, snow blowing, melting. When you're hiking, it's kind of that stuff that's hard to pack down in your snowshoes because it just kind of just goes everywhere. It's more likely to end up being blowing snow. And then column snow kind of slightly on the left-hand side of the image. It's more densely packed, it's thicker snow. It's kind of the snow that will stick to the bottom of your snowshoes. I call that yucky snow because it makes for the day to be a lot harder to move. And next. So when we're trying to figure out what type of condensation nuclei will create snow, we have a lot of different places that can come from. So with marine air, with continental air, will all have kind of different kind of like fingerprints of what kind of snow will create. Now, this becomes really complicated in the Northeast because we can tend to have recirculating storms sometimes where it'll start off as a marine polar and then pull a bunch of junk from the continental air. So, out west, it is a bit different. I have most of my experience with looking at snow in the Northeast. Um, if you're looking to apply, some of this for out west, it is a bit different. But in general, we tend to have a lot of snow that has a, great mix of between the continental and the marine, depending on the storm tracks. And I'll talk more about that in a minute. We are really lucky in the Northeast to have so many different ways we can get snow. And I wish we had more that had actually been successful this year because our snow is still really low for the season. But I just wanted to, show this to show where the storms come from do influence the condensation nuclei. And I think I have more about that on the next slide. And with that, cloud droplet size. So between the continental and marine air, we can have very different snow, not only in the size of the cloud droplet size, but also the count. So depending on where the air mass came from, the size of the cloud droplets can be incredibly different. In general, marine air masses, stuff that comes from, the ocean coming up to the north, will have more and larger droplets than stuff coming from, scooping through the Midwest that will have smaller and fewer droplets. And, as I said, what happens in an individual storm really will change a lot because, in the Northeast, we can have this recirculation. We can get a lot of, junk coming up from, New York City or from, down south that can be kind of more interesting condensation nuclei. There's an entire science to different particles, can have different stuff sticking to them because they have different adherent rates. And that becomes a bigger issue when it comes to acid deposition in the Adirondacks that, folks are really looking into. And I'm gonna hit the next slide. So when we have all of these complex things, that can go into what makes what, snowfall, then it goes into the how warm is it in the atmosphere versus at the ground, and will it even come down as snow? So this becomes slightly more complex when it comes to orographic terrain, um, because the it changes when you have something going up the side of the mountain. But in general, for something to come, for precipitation to come down as, mostly snow, it needs to have kind of a cold air column all the way down. If you have kind of this like wedge of warm air, depending on the size and where that wedge is, and you can see some of this information if you were to look at SKU-T or log-P maps. The State University of Albany has a lot of links to where some of the most recent SKU-T maps are. I will not go over SKU-T maps because again, that's an entire semester of stuff I think I'm going to really bore people with. But what kind of precipitation falls to the ground really is influenced by how warm the atmosphere is. And next. So I wanted to touch a little bit on different types of snowstorms really quick. I know I'm throwing a lot at you guys, but I, hope you can take bits and pieces where you can, think of, other questions to ask, or if it's something I can't answer tonight, I will definitely help you find the resources. But when it comes to trips of more than, a day trip, you really should kind of know the setup of some of these typical storm tracks. Um, so, lake effect snow, lake effects generally is when like a cold air mass moves across the Great Lakes, picks up a ton of extra moisture. Out in Western New York, folks are very, very used to, having to deal with tons and tons and tons of lake effect snow. Um, it snows, the process can be slowed or completely stopped as soon as the lakes freeze over. Lake Erie is normally the only Great Lake except for Lake St. Clair, which will freeze over entirely, but by the end of winter. However, in the winters where they're kind of warmer and they'll have more open water, so it can kind of continue on. And the added warmth and moisture can create a shallow convection layer in different types of snow showers. So it can definitely make for some really interesting snowstorms. Hit the next one. So there's two different types of nor'easters. Usually we'll just kind of hear, just blanket one type of nor'easter on the news or if you're watching the Weather Channel. But this is looking at a type A nor'easter. So nor'easters tend to develop in the Gulf Coast or along the East Coast, along an old cold front, or along a marine and land air mass. This is considered kind of like a classic nor'easter. This, I think it was the superstorm of 1993 that it was a Miller type A. But notice there's a lot of the low pressure is kind of moving along the coast. So you can kind of have this mix of marine and continental air as that low pressure swirls. So you can kind of have, depending on where the front is as it's moving through, you can have either, heavy bands of snow or kind of that light sugary stuff. But this is kind of the typical setup. Next slide. So this is the less common nor'easter. So storms that come from the west of the Ohio Valley, kind of called Miller type B, these storms produce a lot of precipitation in the Midwest Ohio Valley and have a defined structure. The low is moving towards the Appalachian Mountains from the west. As these storms approach the mountain, they lose a lot of their the kind of the coherent, the compact surface low, but then it will kind of redevelop along the east coast. When that redevelopment happens, that's called a center jump. The storms can produce bananas amounts of snow kind of all over the state. But it'll usually kind of have the heaviest snow in kind of like the northeast. Again, this has a lot of, it starts out with continental air and kind of gets that marine air mixed in. So you can have, depending on where the cold front is, kind of a mix of different types of snow. And next slide. So the Alberta Clipper is kind of one of my personal favorites because it's so kind of odd. So clippers are really, really fast moving, and they kind of almost exclusively will have continental air. So we'll have kind of smaller and less amounts of the snow, but sometimes the snow looks a little bit prettier. So the clippers tend to have less snow than nor'easters, but it's kind of can be very fluffy, and it's that stuff that's really kind of hard to pack down as you're snowshoeing. It's when you bring a lot of friends to break trail after a clipper comes through, and it has kind of a low water content, so it's less likely to stick to your snowshoes. It's kind of rare to get other precipitation types besides snow during a clipper. So it's because it kind of has that continental and usually polar air mass, it's unlikely that you're going to get like sleet or freezing rain. It's one of those things that if you say snow, as long as you have the amount right, you're not going to bust your forecast. And next slide. So these in the winter are a lot less common than squall lines. They can happen. They're more unusual. We hear a lot about squall lines kind of with, thunderstorms or, kind of summer weather. They can kind of, an intense squall line can kind of resemble the heaviest lake effect bands, and they kind of steadily move east to west. They have really strong winds as they move through. I would generally steer clear if I thought one was going to come through in the winter, because the winds can make visibility a real problem. Um, Again, they're less common, but they do happen. Next slide. So I know I threw a ton of information. It's kind of like drinking water out of a fire hose. So, and I try to just kind of get the highlights of the interesting and cool parts. So I wanted to provide you guys with, if you wanted to, do further research. The University Corporation for Atmospheric Research is one of the people that operates COMET and their Met Ed service. So there's an entire winter weather distance learning course. It's 9 hours, 12 lessons. They're in the process of moving some of their lessons from Flash to HTML5. So if you click on one of the lessons and it's still saying Flash player not working, just give it a couple weeks and they'll have that settled. There's also, they have their own mountain weather distance learning course where they look at things like the planetary boundary layer, gap winds in the summer, which are really, really cool, and different avalanche risks. And they have I listed some individual courses. So write that down if you feel like I went through stuff way too fast, which I tend to do when I'm like really excited about something. So that, and then next slide. So with meteorology, we definitely stand on the shoulders of giants. So in preparing some of the stuff for this presentation, I just wanted to give a shout out to, some of the folks and presentations that, I bothered a couple people to find out what were the really important stuff. And meteorologist Jeff Habe will always have a special place in my heart for a lot of the information he has. So pop to next slide.
My turn?
Yep.
Perfect. So we showed you guys all of that, or more likely Amanda showed you guys all of that, because it's extremely important to realize how complicated this process can, or is, not can be, is. And so with that, she's obviously a scientist of weather and understanding this knowledge from a science standpoint. I've come to this from the application side, in that I am a ski patroller. and professional ski patroller. So I do it 5 days a week. Um, and so how I use weather is or not how we use weather is the same, but how I interpret weather is completely different than how Amanda does, because I didn't understand 90% of what she said until she taught it to me. So, but the important thing to take away is that there's a ton of extremely smart people out there that are breaking down all the different models, breaking down all the different situations and circumstances and things that are happening, and giving you a forecast, as in a prediction of what they think is going to happen. And so with that, it's important to kind of decipher where you should be going to get this weather knowledge in the planning stages of your trip. And so I kind of conveniently broke this into um, three different lengths of trips. So the short trip is, a weekend trip, leave on a Friday, come back on a Sunday. Um, and it's, where you want to go for your weather forecast is kind of the simpler, um, hard and fast weather forecasts that are going to tell you how to pack accordingly for what type of precipitation could fall throughout the next couple days. And it's very easy to come pretty close to getting it right if it's only a 3-day forecast or less. And so the two main sources that I really like to use from just a weather standpoint is NOAA, National Oceanic Atmospheric and something else, and then Open Snow. NOAA is great for the fact that they give you a quick one sentence about each 12-hour breakdown for a 3-day period, but then they also give you kind of like a cliff notes. The forecaster will put together a quick paragraph or two that explains why they've come up with the conclusion that they've got, and they nail it. They get the weather right usually. The only thing that I think they miss um, fairly regularly is the amount of snowfall that's going to come. Especially, I live in California. They especially miss the forecast, or the amount of snow that's going to fall out here in the West fairly regularly, mostly due to elevation. They they get it right in a broad sense, but we are notorious for getting like 6 inches at 6,000 feet and 30 inches at 9,000 feet. It's very common for us to have a storm that will go 2 or 3 days and we'll only get 6 inches at my house, and I'll get 30, 3+ feet at the mountains in 3 days. And then another source I like to go to is Open Snow. They're kind of a newer group of forecasters, but they're regional specific. So they've got maybe a dozen different folks that are doing a regional forecast. They do one in the Northeast, they do one in all the different mountain ranges out west, and they give you the quick hit, what they think is going to happen in the next couple days. Usually with the next storm that's approaching, they give you a little bit longer range, and then they give you kind of a pattern that they see formulating for maybe a longer range past that. But if you just read the first couple paragraphs of their forecast, you're going to gain a lot of information about what your 3-day trip is going to entail. So the next one is kind of a mid-range trip, 3 to 7 days. And so this is where you need to start getting into maybe some of the more kind of detailed forecasting knowledge, because I live by the rule of, my boss makes us live by this rule of the nowcast. We get a daily forecast briefing, but then we're constantly encouraged to be looking outside and looking around, and as we're patrolling the mountain, kind of paying attention to what the weather's changing and how that differs from the forecast. Um, and so then the other thing that I live and die by is the 10% rule. And so the forecast loses 10% accuracy every day out. So by an important thing to think of is a 5-day trip doesn't seem like that big of a deal. But on your 5th day, the day you're going to supposedly come out of the woods, the forecast that you read right before you left the trip has a 50-50 shot at being accurate as you're walking out of the woods. So keep that in mind. And so with these mid-range trips, you need to start getting into kind of some of you need to a little bit start playing into the regional patterns so that you can understand, hey, when the winds start to crank up from the southwest, that means this type of storm is approaching. Hey, when the winds start to crank from the northeast, that means this type of storm is probably going to be approaching. But also, you can still have a pretty good understanding of what's going to happen based on, the forecast for your specific location. And so, two resources that we like for that in America is mountainforecast.com, and then in Canada is this weather.gc.ca. And they give you they give you more of the complex terms, but they also still simplify it so that us laymen can kind of understand what's going on. And then the next one is the long range trips, more than a week out in the woods. And so this is where the forecast plays less importance and your knowledge of the regional patterns plays a much greater importance, and your knowledge of what the winter's been doing so far and what the mountains look like currently plays a greater knowledge. And so this is where fully understanding, hey, when, like for me, being in the Sierra Nevada mountains a couple hundred miles from the ocean, if the humidity rises and the winds start cranking from the southwest and the temperature rises, I know we're about to have a wild ride for 5 days, and we're going to get 4 inches of rain, 5 feet of snow, and we're not going to see the sun for a week. And it's going to be a lot of fun. But that's it's these regional patterns, kind of the last couple slides that Amanda was hitting at, talking about the different type of storms that can impact the northeast. The same thing is true. If you feel the temperatures plummet and the winds start cranking out of the north a little bit higher, you can anticipate that it's going to get brutally cold. Not going to snow a lot. You're going to get 3, 4, 6, maybe 8 inches of snow, but it's going to get really, really cold for the next day while this Alberta Clipper's coming through. And so paying attention to those regional patterns as you're on day 1, 2, 3, 4, 5 of a 10-day trip is where you're going to really start to make smarter decisions in the mountains in the winter and say, hey, we were going to try and summit X mountain tomorrow, but based on the fact that the winds are cranking up, maybe we should push it and let's see what this incoming storm is going to do. And then with that, there's also at the bottom of the slide, there's 2 paid subscriptions. The weatherbell.com/premium is, and these are affordable on, a general person's budget. The weatherbell.com is $24 a month for a premium subscription, and it's going to start to let you view the models. It's going to start to let you read the synopsis, and then same thing, this Pivotal Weather is $65 a year. This is the one that we use on patrol, is the Pivotal Weather. And it gives you, it's more complicated than what most people can understand. But that being said, the more you read these on a fairly regular basis, you start to understand what these terms, some of these terms can mean, and what some of these terms can mean for you in the mountains specifically. And so the next one is gearing up. So we've talked about what makes the weather happen, what makes it do the various forms of it, and then how to be ready for it as far as forecasting goes. Well, now it's time to pay attention to what gear you need based on the types of weather that we're going to encounter in the mountains in the wintertime. And so the next one is dealing with winter winds. And so this is kind of, in my opinion, winter winds is probably the most dangerous winter weather you can experience. If you're not prepared for winter winds, you're going to be out of luck pretty quickly, and you're going to have a bad outcome on your trip. And so that includes full face protection. You can see in the photo here, there's not an ounce of or an inch of skin showing. Hard shell layers that have good wind blocking, but also breathability to them, and then extra insulation layers. The wind can take what's very common for us is like a 25-degree day Fahrenheit with 60-mile-an-hour winds. When you factor the wind chill of that, that's well below zero. And so even though it's only 25 degrees, an all-day 60-mile-an-hour wind just beats you down. And if you don't have the proper insulation to deal with that, equivalent of negative 25 temperatures, you're going to have a bad day in the mountains. The next one is preparing for a snowstorm. The thing that we all, hopefully you like, if you're interested in winter mountaineering, is you better like being out in the snowstorm. So it's important to remember that as it's snowing, you're going to be working extremely hard. So all those extra layers you needed in the wind event, you might have to take a couple of them back off, even though it's counterintuitive to think that you might need to wear less layers when it's snowstorm. You're going to be working a lot harder. You need to also still be concentrating on your storm shells, your hard shell jacket and pants layer. Extra effort into making sure you stay dry in that snowstorm, and then dealing with flotation, skis or snowshoes to stay on top of all that new snow. The next one, the one that sucks, but you also have to deal with it. We deal with it out here quite a bit. And then sadly, in the Adirondacks, occasionally we deal with it as well, are the winter rains. And so they're probably, I would put winter rains as maybe the second most dangerous weather condition you can experience in the winter behind wind. You need way less layers because most likely it's above 32 degrees, but not by a lot, which is the scary part. Then you kind of have to balance out the rain gear versus hard shell. Rain gear's normally lighter weight, thinner, better breathability, versus the hard shell. It can wet out much easier than the rain gear can. Or I'm sorry, rain gear has less breathability usually, but the hard shell can actually wet out and then freeze later. And then the biggest thing that makes winter rains dangerous is preparing for the inevitable temperature drop that comes right after the rain leaves. 5 minutes after the rain stops, the temperature always plummets. And then everything freezes solid, including the snowpack that you had. So dealing with those could include crampons. The most important one is making sure you stay dry, both from the precipitation and from your perspiration, so that when the temperatures do plummet, you are dry enough that you can stay warm when the temperatures get cold. And then lastly, kind of to pull that all together, is building the overall system. And so this course is not at all geared towards telling you what should be in your backpack, but it's definitely starting to think about that whole clothing system based on the trip that you're going out on. And so back to my 3 different lengths of trips, if I'm going on a 3-day trip, I'm not going to take maybe a certain extra layer. If I'm looking at the forecast, I'm saying, there's a 70% chance I'm not going to need that thing, I'm not taking it. Whereas if it's a 10-day trip, I'm like, oh, I could experience rain, I could experience snow, I could experience 45 degrees, I could experience negative 20 degrees. Okay, now everything I need in that backpack just got a little bit bigger. And so thinking about building your clothing system, your layering system, your gear system, so that things are multi-use items, and then knowing how they work for you in various weather conditions. And all this comes with experience. What I will say is, on our website, we have our required and recommended gear lists for all of our various trips. And those are excellent resource to start for trips to um, the Northeast mountains in the winter, including the Catskills as well. And then lastly, Amanda's going to wrap up planning. And then one thing I forgot to share in the beginning is we're on the home stretch. If any of you guys have any questions, please type them into the chat feature. We're going to stick around for a few minutes and answer as many questions as people are willing to stay awake for.
So I just have a lot of this Jeremy has already gone over. I'm a very visual person. So if you want to skip 2 slides ahead to forecast accuracy. So
Oh, I stole your thunder.
oh no, I just, I'm one of those sick people. I love Excel. So I just threw in, kind of like what the forecasted temperature can, and I'm sorry if anybody is red, green, colorblind. But so in the center is kind of the forecasted temperature in yellow. And as you go from the days of the forecast, the forecasted temperature can be widely different. Now, temperature is actually one of the things that's usually the most accurate. When you go to precipitation 7 days out, I don't trust it. And especially if, they're saying something's going to be, either a glancing blow from a larger storm or something that, could hit directly. Just, again, reiterating Jeremy's 10% rule. A lot of times when we're thinking about hiking in the next weekend, we start looking at the weather, on Monday for a hike on Saturday. So don't take anything out of your pack thinking you're not going to need it on Monday for the hike that's coming on Saturday. Um, and going through, I have it's lots of stuff we really, we have gone over in the next couple slides. Um, one thing, if you want to skip 3 slides ahead to know the weather a few days before your trip, uh, 2 more. So this is something that became kind of a big deal this year, is rain in the Adirondacks. I was in the Adirondacks for a Christmas hiking trip, socially distanced, ate mashed potatoes from the microwave on Christmas Day to make sure we didn't bother anybody at a restaurant, like true champions. But again, rain can really mess up your day. So, when you're looking, at the forecast going forward, also take a look at the forecast going backwards. We actually canceled a couple of our hikes that we had been planning because of flooding, because there was a really, a big rainfall event that happened on the 26th. So all of this great, lovely snow that we had been like super excited for, like had my, I sharpened up my crampons and I had my snowshoes all nice and pretty, took all the rust off them. Most of that snow was gone by the 26th because of a rainstorm. So, there was people that were having issues with water crossings because all of that snow had melted. So as you're looking forward for a trip, so again, look backwards. And then I want to pop to the next slide. And a couple other random bits and bobs that I, really wanted to make sure I mentioned. There's a lot of folks I see in the different interwebs, Facebooky groups of like, it's going to be a great warm day for hiking. In the winter, sometimes warm temperatures aren't great. We've all, had to hike somewhere with our micro spikes that everybody seems to love, or our snowshoes, and everything is sticking to the bottom, or skis when you have to, get the credit card out and scrape all the snow and ice off the bottom of the skis. you know, Temperatures up in the 30s and 40s can really degrade a snowpack. So it's something to think about as you're moving forward. You could be starting a hike at, the wonderful temperature, 15 degrees is like my favorite, with 15 degrees, no wind, bright sunny day, great hike up. But as you're hiking down, if that snowpack is degrading and you're having to constantly kick the snow off of your traction, it's going to really slow you down on the way out. So, but the most important thing with hiking is making sure you get home. So it's not just thinking about what the forecast is going to be till you get to the summit, but also on the way out. And then warm, wet days, preceding colder weather, significant icing. There was a lot of people who were really, I think, excited for the snow for the first half of the winter in the Adirondacks, and just got bananas ice, and I think some folks were kind of taken by surprise for that. So just something to keep in mind. And then I just have the forecast things that I use. Also got a shout out DEC trail conditions. If something's washed out, if something's has a ton of blowdown, like 2 Halloweens ago, the Halloween storm created a ton of blowdown. They're still working to clear some of those trails, mountain forecast, and we're really, really lucky in the Northeast. The National Weather Service does mountain point forecasts, usually about 2 or 3 days out. I think they have it go about at 3 p.m. and around 3 a.m. So always make sure you're checking the forecast right before you go out in the morning. If you're, early birds like me, they do a couple of the summits in the Northeast, and I think that is it for me.
Wow.
Hooray!
Let's see. Okay. Let's see what questions we have. I see one. Oh, that's a long one. I wasn't able to get on until. Do you see that, Amanda?
From Arthur.
In the Q&A section,
Oh, jeepers.
not the chat.
Oh, we have
Art's
one.
a Art's a former instructor. He's saying hi.
Ooh, sunrises and sunsets. So that depends.
I don't think they can see the question.
So the question is, if they're curious of any advice on reading weather patterns, whether from professional forecast or from in-person observations, to be able to tell if the morning or evening we're more likely to have a beautiful sunrise or sunset, or if there's any way to predict the days that are have a higher chance of being above the clouds and the top of mountains. So for being above the clouds and having the clouds underneath you, it's actually called an inversion. We had a couple days in a row in the Adirondacks where we had an inversion. It's where the temperature, I believe, is increasing with height. So then the cloud tops are a bit lower. I had to deal with that quite a bit at my job because we actually have an air quality monitor on the top of Whiteface Mountain. And when there's an inversion, we can see all sorts of weird stuff we usually don't get to see. You
That was going to be my high extended high pressure.
Yes.
Is whenever, it sucks as far as the skiing goes, but it does make for some amazing sunrises and sunsets. When you get into a prolonged high pressure, anything more than like 3 or 4 days on the coast, or maybe probably realistically in the continental area, anything more than 2 days, you can really start to get those amazing sunrises and sunsets. Sunrises are easier to predict because if you wake up a couple hours before the sun rises, if you see nothing but stars, you're going to have a good sunrise. Sunsets are definitely much trickier to predict. Oftentimes, and Amanda can probably explain why this is the case, but oftentimes the weather on a clear, nice day, the weather can deteriorate throughout the day, and how it is in the morning is not how it's going to be in the evening. And so a sunset is less easy to find. I will say they seem to become more common in the spring. And Amanda can probably give you the science as to why that's the case.
In a 10-second clip, it's, the turbulence increases throughout the day. So we're getting the heating of the lower atmosphere, stuff's kind of lava lamping and bobbing up to the higher levels of the atmosphere, but definitely extended high pressure, which also can make things very, very cold. So if you want to get those really nice sunrise pictures, make sure that you have, hand warmers. Anytime I've done sunrise hikes, cups of coffee, and making sure that you have, your headlamp ready. And the other thing with pretty sunrises and sunsets, unfortunately, when there are wildfires, sometimes in the western part of the U.S., those particles can contribute to having kind of prettier sunrises on the East Coast. So that's something to think about, unfortunately.
Dave asks if we can make our slides available after the meeting. I don't care. We certainly can. Do you care?
Sure.
So the easiest way to do that would be shoot us a message on our wintermountaineeringschool.org website. Go to our website, shoot us a message on that. I'm the one that gets those. I can forward the slide, the presentation on to whomever is interested. And just like that, I'm going to get 30 emails tonight. Any other questions from anybody? We did that good of a job that there were only two, huh?
In the chat, it says, what are those links again at the end?
I can put them up and you can screenshot it. Give me a second. Where is it? There it is. No, come on. Go back. That one, I believe, is the one they want. There you go. Is that visible? I think that's the links everybody was looking for.
I think so.
Okay. Everybody get a screenshot of that wanted it?
We got a yes.
Yes, perfect. Come on.
Oh,
Where's the?
we have
Oh, there we go.
another question from Johnny. One more on weather patterns. You get to the top of the mountains and you're socked in. Is there any way to tell if it's worth sticking around to see if it clears up?
Ooh. The short answer is it doesn't.
Yeah, I'm trying to think of like the
I
so
would.
that part of that cedar, the orographic uplift. The mountains are kind of creating the clouds you might be seeing. Um,
In a winter weather pattern, I would say probably not. The one thing I will say is like a summer thunderstorm. It's not safe to be hanging out on the top, but it's always worth hanging out below the top when a winter thunderstorm's coming in, as long as you're not, fully exposed and out in the open to just get kicked. But um, sometimes those things can fly right past you in 30, 40 minutes and not screw up your day too badly, or even 10 or 15 minutes. But as far as winter goes, that's a tougher get. Normally, my experience has been that when it's getting it on the summit of a mountain, or that being said, even a larger mountain like Mount Rainier. I did Mount Rainier a handful of years ago, and in camp we were fine. Camp at 11,000, it was fine. It was great, but you could not see the summit, and we were one of two teams that day to actually summit, and it was just blowing, nasty, miserable. And it was from 3 o'clock in the morning when we left 11,000 feet to 9 o'clock when we reached the summit to 1 in the afternoon when we were back at camp. Still couldn't see the summit. And so in situations like that, a standalone peak like Mount Rainier, now it's never gonna, it doesn't, if it's there, it's not going away until the weather pushes it out. Um, but in the summertime, it seems more likely that you can get a quick thunderstorm to blow through and actually enjoy it.
yeah, everything kind of sticks around a bit more in the winter. And
I
then in the
do.
summer, depending on what the day is like, you can actually see the clouds kind of be created on one side of the mountain. And this happened, I think, when I was on Marcy 2 years ago. So, of course, I'm the nerd going, orographic uplift. And everybody's like, what the heck? And you can see the clouds being created. And then on the other side of the mountain, they just completely disappear.
It is cool.
Um,
That's super
like
cool.
in the winter, I almost never get a view in the winter. Just and unfortunately, if it's sucked in when you get there, there's nothing worse than turning around and seeing the person that you passed as you were going down and they were going up are going to get a view. But it's almost impossible to predict.
Mm-hmm. Agreed. Anything else? No. All right. Well, then I'll wrap it up with our spiel one last time. So go check out our website, wintermountaineeringschool.org. We're really, really, really hoping to be back in the Adirondacks and the White Mountains for 2022. We'll start planning it this spring, and the best news is I won't be in charge anymore. I just get to go back to being a regular instructor instead of the director. Um, and then another thing is you guys are all now officially alumni of Winter Mountaineering School after a 1 hour Zoom course. So go join our Facebook group. It's what is it? I think it's WMS alumni is what it is. WMS alumni on Facebook. There's a bunch of good resources on there. Most of us are on there. Some instructors are much more active than others, but it's a good place, good resource, crowdsourced resource to get information about Winter Mountaineering School and gear and trips and finding partners and so on and so forth. Yeah, that's our spiel. Amanda, do you have anything else?
We had a question of who is the next director.
A handsome young man named Rich Murray he's currently, so we do, it's a 4 year process. You're assistant director for 2 years and then director for 2 years, and then you get to retire from it. I My process didn't quite go like that. I was just the director for 3 years, which I wouldn't recommend to anybody else. But the good news is I got to short it by 1 year. The bad news was I didn't know what I was doing my first year. So, but yeah, it's a fun process. We're a group of 25 or so people that love the Adirondacks so much that we give up a week of our time every year to come and teach mountaineering skills. And Amanda's one of our newest instructors. This is her first year instructing via Zoom. So, is that it? Oh, Art was asking that. Come on, Art's one of our retired instructors. But yeah, anyways, on that note, everyone have a good evening and thanks for attending.
Bye, everybody.